Okay, this is worksheet number 5, uh, precipitation and acid-base reactions. As always, don't forget to start with writing your name and student ID. Do not lose point. So we have some recalling principles before we start the problems. So what is a precipitate? So precipitate is an insoluble ionic compound which is formed in solution. So when you're mixing two solutions and the new ionic compound is insoluble in the solution, it crushes out. Sometimes in chemistry they do that to measure the amount of something. They want to calculate the amount of something. You've probably had that if you had Jenkins lab in the experiment of limestone. They use the precipitation concept to crush out one of the cations and to measure out the limestone in water sample. Okay, so what is Bromstead-Lowry acids? So in the lecture slides we talked about Arrhenius acid and base. We said something about Bromstead-Lowry, but we have this question here. So this chart might help. So acid and base, right? So from Arrhenius definition, any substance that produces H plus is acid. Any substance that produces OH minus is base, right? From Bronsted-Lowry, I write BL. Sometimes they say Lowry, acid or base. So proton, and we know that H plus is proton. Proton donor is acid, and proton acceptor is base. We have another definition for acid and base, which is Lewis acid and base. So Lewis acid and base, if a substance is electron acceptor, is an acid. If it's electron donor, it's a base. Okay, so Lowry-Bronsted acid, it's a substance that can donate H plus or proton. That would be an acid. Okay, well, I guess it's good to know the definition in all these three types of definition of acid and base, but we mainly focus on Arrhenius acid and base in the lecture. Okay, so practice problems. We've learned how to write chemical equations, how to balance them. The first one is a precipitation reaction. So we have these two ionic compounds and we want to write the balanced chemical equation for this reaction. Okay, so we have silver nitride and it's aqueous plus potassium sulfate, aqueous. What products do we make? So we know they swap the partners, right? So the cation from the first one goes with the anion of the second one, okay? And the cation from the second one goes with the anion of the first one. So Ag, you know, it's +1 because nitrate is -1. You have to memorize the polyatomic ions, and since we have one Ag, so it should be +1 charge. Okay, so you have +1, and the anion of the second one is sulfate, SO4. Sulfate is 2-, you know that, you have to memorize it. So you have 2-, it should be charge balanced, and you have 1+ charge, so we need 2 silver to make it charge balanced. Okay, so that's our compound. So when you write a compound, you erase the charge. Okay, so That's our first one. And the cation from the second one, we have potassium, and you know potassium is a metal in group 1. It's +1 charge. It has +1 charge. And nitrate is a polyatomic ion. It has -1 charge. It is charge balanced already, so you don't need to do anything else. I just erase the charges. Okay, so then we have to check the solubility rules to see if you're making precipitate. So I once again write it here, the solubility rules. Well, there are 2 tables in the lecture notes that you have to memorize them, but this cover most of the things. It just helps to check your compound with this, but you are responsible to memorize both tables. Okay, so cash NGL and GR, and I said that in the lecture notes as well. So chlorates are all soluble, acetate and ammonium salts. Ammonium salts are soluble. Sulfates are soluble except if they are with CBS, the channel, which is calcium, barium, and strontium, happy, HAP, happy, which is Hg 2 plus, Hg plus, and Pb 2 plus. Okay, if it's with these 6 ions, it's insoluble, otherwise it's soluble. Halides are soluble except if it's with these 3 ions, happy. And nitrates are soluble, no exception. And group 1 metals, so it's group 1A metals are soluble, no exceptions, which is potassium, lithium, sodium. All the metals in the group 1 are soluble salts. Okay, so this one is both nitrate and group 1. Both of these 2 are no exception soluble, so this is definitely soluble. Sulfates are soluble except with these 6 ions, and silver was one of them. So silver sulfate is a precipitate, so it's S. Okay, so this is our chemical equation. We have to check if it's balanced. It's better to balance the ionic equation based on the ions instead of elements. So we have silver, we have nitrate, we have potassium, and we have sulfates. Okay, so let me change the color. So silver, we have 1, nitrate, we have 1, potassium, how many potassium do we have? This 2 says we have 2 potassium, and we have 1 sulfate in the reactant. In product, we have 2 silver, 1 nitrate, 1 potassium, and 1 sulfate. To balance it, the first one, Ag, silver, we have 1 in the reactant, 2 in the product. So if I write 2 here, now I have 2 silver, and also I have 2 nitrate. So this changed the equilibrium, so I need 2 nitrate in the product. Nitrate is here, so if I write 2, now I have 2 nitrate. Also I have 2 potassium. You have 2 potassium in the reactants, and it's 1 and 1. So now it's balanced. Okay, so this is a balanced chemical equation for the reaction between silver nitrate and potassium sulfate. Okay, the next question asks for a complete ionic equation for the same reaction. So we already have a balanced chemical equation, a molecular chemical equation, and we talked about this in the lecture notes. To write a complete ionic equation, we just separate anything that we have as a soluble. We have AQ, we write in the ionic form, and anything we have as a solid or liquid or gas, we just keep it as it is. Okay, Okay, so our first compound, we have 2Ag plus AQ. We have 2 nitrates, AQ. Potassium sulfate is aqueous, so we can write 2K plus AQ. And again, the subscript here, it shows that you have 2 of potassium ion. Okay, so when you're writing the ionic equation, you do not write 2 as a subscript. You just put it as a coefficient to show that you have 2 of potassium ion. Okay, and how many sulfate do we have? We have 1 sulfate, so SO4 2 minus. It's a sulfate ion. It's a polyatomic ion that you have to memorize. So these are the reactants. For the products, the first one is a solid, so we do not write the ion, it just stays there as solid. So Ag2SO4, solid state. And the next one is aqueous, so you have 2 potassium, aqueous, and you have 2 nitrates, aqueous. Okay, so that's a complete ionic equation. The next question is asking for net ionic equation. Okay, so for net ionic equation, we just cancel out the spectator ions, and those are the ions that does not participate in the reaction, and write whatever left from the reaction. So from the above reaction, from the complete ionic equation, we see that we have 2 nitrates in the reactants and 2 nitrates in the product, 2 potassium from the reactant from the product and 2 potassium from the reactants. So we cannot cancel out anything else because this is solid. So what's left is the net ionic equation. So the net ionic equation for this reaction is 2Ag plus aqueous plus sulfate, 2 minus aqueous will make Ag2SO4S. That's the net ionic equation. Okay, the last question is neutralization reaction. So neutralization reaction of sulfuric acid and potassium hydroxide. What is the product of neutralization reaction? Always salt and water. Okay, so neutralization reaction is just like the precipitation reaction. We have the swap of partners. Okay, so we have H2SO4 and it's aqueous plus KOH, aqueous. So the H plus goes with the OH and that makes the water, and the cation from the base goes with the anion from the acid to make the salt. So I write the salt first. So the cation is K plus, the cation is A plus, the anion is sulfate, SO4 2 minus. To make a charge balance, you have 2 negative charge and 1 positive charge, so we need 2 potassium to make a charge balance. So after I'm done with writing the formula, I need to erase the charge. Okay, so that's our compound, and sulfate with potassium is aqueous plus H plus with OH makes water, right? It's H and OH is water, it's H2O. And what's the phase? Well, water is liquid, it's not aqueous. Aqueous is something that is hydrated with the water, but water itself is liquid. So we need to balance it. So again, it's easier to balance it based on ions instead of elements. So we have H plus, we have sulfate, we have potassium, and we have hydroxide. So when you're using ions instead of elements, do not mix up when you have H and OH, because when you're counting H, do not count the hydrogen in hydroxide. Okay, you have to be careful with that. So how many H plus do we have in the reactants? H plus comes from the acid, and H2SO4 sulfuric acid is a polyprotic acid, so it has two protons, 2H plus. So we have 2H plus in the reactants, we have one sulfate, we have one potassium, and one hydroxide. On the product side, how many H plus do we have? H2O doesn't have 2H plus, it has one H and one OH. That's why I write it like this. Okay, so there's one H plus and one OH minus. You have to be careful with that. So there's one H plus sulfate, there's one potassium, we have two, and OH we have one. So now let's balance it. So H plus, we have two in the reactants, one in the product. So H plus is here, so we need two. So I write two here. So therefore it's two, and we also have two hydroxide as well. So I change this one to two. And sulfate is one and one, it's already balanced. Potassium, we have two in the product, one in the reactant, so we need two of that. So if I write two here, now I have two potassium, I also have two hydroxides. So I already balanced the hydroxide as well. So this is the balanced chemical equation, neutralization reaction for sulfuric acid and OH. If you want to write the complete ionic equation, so let me erase this part. So if I want to write the complete ionic equation, we have H plus aqueous, we have 2H plus, we have one sulfate, 2 minus aqueous, we have two potassium ions and two hydroxide ions. That will make two potassium and one SO4, 2 minus aqueous. For water, since it's liquid, we do not write the ions, so we keep it as it is. We have two H2O liquid. Okay, and to write the net ionic equation, we cancel out the spectator ions. We have sulfate, we have two potassium, and the net ionic equation is 2 H plus AQ plus 2 OH minus AQ gives off 2 H2O liquid, and since all of them are 2, you can divide the whole reaction by 2, and it will be H plus OH minus gives off 1 H2O liquid. And as I said in the lecture notes, always for all the neutralization reaction, the net ionic equation is the same.